So now we are doing the 2012 free response question number 5, part C. So part C says to use separation of variables to find y equals b of t, the particular solution to the differential equation with initial condition b of 0 equals 20. So this is starting with our equation, our differential equation, which is db dt equals 1/5 times 100 minus b. So to do separation of variables, and it was nice of them to tell us to use separation of variables so we know what technique to use. We didn't have to think about that too hard. So separation of variables means I want the b's over here and I want the t's over here. So we're going to bring the 100 minus b over here, but since I'm dividing by that 100 minus b, I have 1 over 100 minus b, and I'm going to keep my db here. And then when I bring my dt to the other side, I'm going to still have the 1/5 there, so I have 1/5 dt. So now I've got my b's on this side, my dt's on this side, so I've separated my variables. Now my next step is I need to integrate both sides. This side is easy to integrate. 1/5, if I integrate it, is going to be just 1/5 t. And then I have a plus c there. On this side, I'm going to do an integral, and I have to keep in mind how I'm going to do this integral with this 100 minus b in the denominator. So one thing to keep in mind is we need to know that the integral of 1 over x dx is equal to the ln of the absolute value of x plus c. So if I have the integral of a 1 over x, that's going to give me an ln. The other thing that I need to know is that there's going to be a u substitution here, because I don't just have 1 over x, I have 1 over 100 minus b. So I'm going to do a u substitution of u equals 100 minus b, and that means that the du is going to be negative db, and therefore negative du equals db. However, we're going to do a shortcut on the u substitution, which is that whenever we do an integral of a linear u substitution, so this u substitution is linear because it's in the form ax plus b, and so I just have a coefficient of b that's -1. I don't have b squared, I don't have sine of b, it's just a nice linear function. So what I can do in that case is just take the coefficient of b, which is the -1, and I do 1 over that, 1 over -1. And then I do my integration as though this 100 minus b were just x. So I have ln of absolute value of 100 minus b. So that's that integral on that side using a shortcut u substitution. So I'm really doing from here to here this substitution u equals 100 minus b, but I wouldn't even write this out. And you probably are to a point in your studies by now that if you see this linear substitution, you can just turn that coefficient of the variable with respect to which you're integrating over. So we're going to have 1 over -1. If this were a 4 here, we would have 1/4 here. And then we keep the inside function the same, so that 100 minus b stays 100 minus b. And you can check that using a chain rule by deriving back. Now we have negative ln, and when we do this ln and we get this absolute value, it's always a good idea to see if there's some way we can eliminate that absolute value, because absolute value is often very thorny to work with. So what we want to do is look back at our problem and see if there's a reason that we know this 100 minus b is always positive or always negative. And in fact, we had to consider that for the previous part of the problem too, where we looked at the graph. Well, this isn't our graph, but we know that the adult weight of the bird is 100, so the weight is never going to exceed 100. So we could also say that because if the weight of the bird did exceed 100, then dB dt would be negative and the bird would start shrinking, which would be very unnatural. So 100 minus b must always be positive. 100 minus b must be positive, so we can drop the absolute value and just call that 100 minus b. And then that equals 1/5 t plus c. Now our job is to solve this for b. So right now we have a relationship between b and t, but in order to say that we've found a solution for the equation, we really need to get that b by itself. And one thing we might do is find the value of c right away, because we have this particular solution. So the particular solution, actually the initial condition, is b of 0 equals 20. So since b of 0 equals 20, that means that when t is equal to 0, the b is equal to 20. So we can take that information and plug it in here and find out what the c is. So then I would have negative ln of 100 minus 20 equals 1/5 times 0 plus c. Now I know that negative ln of 80 equals c. So c equals negative ln 80. And that's nice for me to know. I know c equals negative ln 80. And that, now that I have what the c is, I can take that c and plug it back into my equation up here that still has the c in it. And then I can say that negative ln of 100 minus b equals 1/5 t minus ln of 80. So that's taking this negative ln 80, plugging it in for the c here, and then I'm bringing that equation down to here. Now, my job is really to get the b by itself, and I think we're not going to get the points on this question unless we get the b by itself so that we can say that we've stated this solution explicitly. We really have everything we need here. But we need to get this b by itself. So let's first multiply everything through by negative 1, get rid of this negative in the front. So ln of 100 minus b equals negative 1/5 t plus ln 80. And then we want to get rid of this ln. So what we're going to do to get rid of the ln is we're going to raise both sides of the equation as a power of e. So we're going to do e to this side and e to this side. When we do e to the power of ln, that e and the ln are going to cancel out, and then we just have on this side 100 minus b. Over here, nothing cancels out, so I have to have e to the negative 1/5 t plus ln of 80. Now I still need to get the b by itself, so I'm going to subtract the 100 over and say negative b equals e to the negative 1/5 t plus ln 80 minus 100. And then I'm going to multiply both sides by negative 1. b equals e to the negative 1/5 t, what is it? Negative e to the negative 1/5 t plus ln 80 plus 100. Now there's one last thing that we can do to simplify this. We've already got the point here, but just for the sake of simplifying this a little bit more, this e to a sum of powers can separate. We'd really like this e and this ln to cancel out, but they aren't going to do so immediately because of this plus sign. But I do know that e to the x times e to the y is equal to e to the x plus y. That means that e to the x plus y must be equal to e to the x times e to the y. I could use this to break up. See, I have a plus sign in my in my exponent. I can break that up as a product. So I can take this plus sign and break it up as a product also. And then I would have my b equal to negative e to the negative 1/5 t times e to the ln 80. And then I have my plus 100. Then the e to the ln can cancel out. And I can really just say that this is equal to negative 80 e to the negative 1/5 t plus 100. And that's what my b is. So I've really solved it here, but I made it look a little nicer here. This looks a little nicer because it doesn't have as messy an exponent. So that's my solution for b. And that is my particular solution for part C. I have indeed used separation of variables to find y equals b of t, the particular solution with initial condition b of 0 equals 20. And that's my solution right there.